Have you ever pondered why Mercury and Venus, our solar system's closest neighbours, have no moons? A question that has intrigued astronomers for centuries, and yet remains one of the unsolved mysteries of our cosmos. As we journey through the vast expanse of our solar system, we find that each planet has a unique story to tell. And today we turn our gaze towards Mercury and Venus, the two planets that stand alone without the company of a moon. Our solar system, a celestial tapestry, is woven with an array of planets, dwarf planets, asteroids and comets, all orbiting the Sun. As we move away from the Sun, we encounter Mercury, the smallest planet, and then Venus, the brightest object in our night sky after the Moon. Both these planets share a unique characteristic. They are the only planets in our solar system that do not have moons. The sight of Jupiter with its 4 Galilean moons, or Saturn with its dazzling ring system and dozens of moons, paints a contrasting picture to the solitary existence of Mercury and Venus. This disparity prompts us to wonder, why is it that these two planets, situated so close to us, do not have moons? There are several theories floating in the scientific community that attempt to answer this question. Some propose that these planets once had moons that were lost over time due to a variety of reasons, while others suggest that they never had moons at all. Each theory brings with it a fresh perspective, a new piece of the puzzle to help us understand the enigmatic nature of our solar system. So, what could be the reasons that these two planets stand out in such a peculiar way? The answer to this question takes us on an intriguing journey, a voyage that navigates through the realms of proximity, impacts, and captures. Let's delve deeper into the mysteries of our solar system. So buckle up your seatbelts and let's set off on this cosmic expedition. One theory suggests that Mercury and Venus's close proximity to the Sun plays a crucial role in their moonless state. Imagine Mercury and Venus, the innermost planets of our solar system, orbiting close to the Sun. Now, picture the Sun as an enormous magnet, its gravitational pull reaching out to everything within its vicinity. The closer an object is to the Sun, the stronger this gravitational pull becomes. This is where the proximity theory comes into play. It suggests that the Sun's gravitational influence on Mercury and Venus is so strong that it effectively disrupts the gravity of these planets. This disruption could prevent them from holding on to any moons of their own. Let's delve a bit deeper. In our solar system, moons are typically tidally locked with their planets. This means one side of the moon always faces its planet, just like our own moon does with Earth. Tidal locking is a result of gravitational interaction between a planet and its moon. However, for a moon to exist, a delicate balance of gravitational forces is required. If a moon were to orbit Mercury or Venus, the Sun's powerful gravity would compete with the gravity of these planets. The Sun could potentially destabilize the moon's orbit, causing it to drift away or even crash into the planet. This gravitational tug-of-war could make it extremely difficult for Mercury and Venus to maintain their own moons. Moreover, the Sun's intense gravitational pull could cause what's known as gravitational disruption. This disruption could rip apart any moon that strays too close, scattering its remnants into space. Such a scenario could explain why Mercury and Venus have no moons today. To put it simply, the Sun is like a cosmic bully, using its gravitational might to push around the smaller objects in its neighborhood. The closer the objects are, like Mercury and Venus, the harder it is for them to stand their ground and keep their moons. Therefore, the overwhelming influence of the Sun's gravity could be one plausible explanation for the absence of moons around Mercury and Venus. Another theory ventures into the violent past of these planets and suggests that any moons they might have had were lost due to catastrophic impacts. In the vast expanse of our universe, celestial bodies are constantly in motion, and collisions, though rare, are an integral part of this cosmic dance. The impact theory proposes that Mercury and Venus may have once had moons that were obliterated or ejected from their orbits due to cataclysmic impacts. Picture cosmic billiards on a grand scale, with planets and moons as the players. An external object such as a comet or asteroid could strike a moon with enough force to shatter it into countless fragments or push it out of its host planet's gravitational pull. This theory isn't as far-fetched as it might sound. In fact, it's similar to the widely accepted giant impact hypothesis, which explains the origin of our own moon. According to this hypothesis, about 4.5 billion years ago, a Mars-sized body collided with the young Earth. The impact was so violent that a large part of our planet was ejected into space, eventually coalescing to form the Moon. Similarly, any moons of Mercury and Venus might have met a destructive end. The inner solar system, where these planets are located, is a tumultuous place, densely populated with asteroids and comets. It's plausible that over billions of years, numerous collisions could have occurred, leading to the destruction or ejection of any moons these planets might have had. However, it's also worth noting that the impact theory, like the proximity theory, is still just that, a theory. While it provides a compelling explanation, it's not definitive proof. Scientists continue to study and explore these fascinating planets, hoping to unravel the mysteries of their moonless state. As a result, the violent history of these planets may have left them bereft of any moons. A third theory posits that Mercury and Venus may have simply failed to capture a moon. Now, let's delve into the intriguing world of the capture theory. This theory suggests that some moons are not born alongside their parent planet, but are instead cosmic drifters, snared by the gravitational pull of a planet as they pass by. Imagine a celestial body wandering through the vast expanse of space and, by chance, straying too close to a planet. The planet's gravity acts like an invisible lasso, pulling this wanderer into an orbit around it. In this manner, the wandering body becomes a captured moon. However, for the capture theory to hold, the incoming body must lose some of its kinetic energy, the energy it possesses due to its motion. This can typically happen through interactions with the planet's atmosphere or other celestial bodies. Without this loss of energy, the potential moon would simply slingshot around the planet and continue on its merry way across the cosmos. So why might this process not have occurred for Mercury and Venus? Well, Mercury is the smallest planet in our solar system, and its gravitational pull is relatively weak. It's unlikely that it could snare a passing body and hold it in a stable orbit. On the other hand, Venus, while it does have a stronger gravitational pull than Mercury, has a very dense and slow-moving atmosphere. This could make it difficult for a passing body to lose the necessary kinetic energy to be captured without being vaporized by atmospheric friction. Moreover, both Mercury and Venus orbit relatively close to the Sun. The Sun's immense gravity can destabilize their potential moon's orbits, causing these bodies to either crash into the planet or be flung back out into space. Thus, the lack of a captured moon might be another piece of the puzzle explaining why Mercury and Venus are without moons. The absence of moons around Mercury and Venus is a fascinating aspect of our solar system's architecture. It's a puzzle that has captivated astronomers and casual stargazers alike. We've journeyed through the cosmos together, exploring the possible explanations behind this lunar absence. Let's take a moment to recap the theories we've examined. Firstly, we discussed the proximity theory. This theory suggests that the close proximity of Mercury and Venus to the Sun could have resulted in any potential moons being pulled away by the Sun's strong gravitational force. A tug-of-war of cosmic proportions, if you will, where the Sun always emerges victorious. Then we moved on to the impact theory. According to this theory, it's possible that both planets may have once had moons, but they were obliterated in violent celestial collisions. The remnants of these moons could have either crashed onto the planets, been ejected out into space, or even been incorporated into the planet's mass. Lastly, we delved into the capture theory. This theory posits that neither Mercury nor Venus managed to capture a moon, a process that requires a delicate balance of speed and gravitational pull. Just like a cosmic dance, where the slightest misstep can lead to disaster, or in this case, a moonless planet. These theories, each with its own merits and challenges, offer intriguing possibilities. They allow us to ponder, to question, and to continue our quest for knowledge. After all, the beauty of science lies in its endless pursuit of answers. However, it's important to remember that these theories are not definitive explanations. They are educated guesses, tools for understanding that are subject to change as our knowledge and technology advance. While we may never know the exact reasons, these theories provide us with intriguing possibilities and remind us that there is still so much to discover about our own cosmic neighborhood. So let's keep looking up, keep questioning, and keep exploring. For in the vast expanse of the cosmos, there are always new mysteries waiting to be unraveled.